Hi, Mr. Morales. I'm Berkeley to finally get to put a face to an email. For my ISU, I'll be doing the index of refraction test with vegetable oil and Pyrex glass. So for this experiment, as I mentioned, we will be testing the index of refraction. The materials that I have in front of me are 3 different glasses: a beaker that is Pyrex glass, a test tube that is Pyrex glass filled with vegetable oil, and this is filled with water, and this is filled with vegetable oil and water as well, just to get a little difference when I'm doing the experiment. We can see this test tube here in the water. You see that even though it's the same transparency, you can see that it looks a lot bigger when it's in the water, which is a common property of glass and light in water. So with this, what you actually see here is the air in the Pyrex tube. That is a different index of refraction than the vegetable oil. Now, once we fill it with vegetable oil, it disappears when it enters the vegetable oil. This is because the index of refraction in Pyrex glass, it has to be Pyrex glass, not any other type of glass. Vegetable oil is very similar at 1.147 is the ratio, whereas the index of refraction for water is 1.33 opposed to 1.147. Let's do another contrast test here. As I put it through this, it disappears, but it comes right back out in the water. Thus, Pyrex has light passing straight through it, the Pyrex and the vegetable oil, with no visible bending of the light because their index of refraction are the same. So the invisibility is due in part to because we don't actually see things unless light is passing through it or reflecting off of it. So what we see around us is due to the way that light reflects off of things, or in this case, how light refracts through things. Now, to reassert and better understand our knowledge of refraction and its properties, I'm going to perform one more experiment, and this one is called the disappearing coin trick. So for this experiment, we want to get a different idea of the invisibility properties of light and images and how they all work. This coin here will be placed underneath this glass. Now, from every angle we look at it, we can of course see the coin. The image is a little bit morphed from the refractive properties of light, but it's still visible. Now I'm going to pour water into the glass. As you can see, the coin disappears. Most angles you look at, you cannot see the coin. So this is why we place the saucer on top, because if you do look right over top, you can see the coin. And this is because the bending of the light and the image projected bends so that we cannot actually see the image with our eyes from the angles that we look at it, aside from right over top. That is how we do that experiment. So those are my 2 experiments, and I've attached on my written component a couple of links to websites that explain with more diagrams how refraction works and how the invisibility properties are produced. There's also a simulator that I have attached as well. So thank you for listening to my ISU.